Today's webinar is going to be about an igus product known as Guidefast. It's a faster and easier energy chain alternative to conventional Festoon systems. Starting off, we'll just talk about the current status quo with a lot of indoor crane and shop hoist applications, and that is the humble Festoon system. About as long as electric overhead traveling cranes have been in existence, they've been using Festoon systems. It's a very simple way of cable management where the cable is just looped over some trolleys. And as the hoist moves back and forth across the crane beam, the cable is towed back and forth along with the hoist to supply the electrical power. Typically uses either flat or round cables depending on the configuration. The cables are typically clamped off to each trolley and they run inside of a rail like we see on the screen in this photo. So it's worked fairly well for a number of years. However, as demands have been are increasing and customers are trying to improve the technology, the capability, the flexibility of their equipment, and also a need for faster installation, faster output has arisen. There certainly have some drawbacks of the Festoon system have become apparent. And igus has noticed that and is attempting to address those drawbacks with the use of our Guidefast product. So the Guidefast product is pictured in this photo right here, attached to a crane. What the Guidefast product is it's a specialized trough system that allows a conventional energy chain system to be side mounted onto a crane very quickly and easily. igus energy chains have been around for a number of years, 50 plus years, but they've been used on cranes for about that long. The idea of the Guidefast product is to allow the energy chain system to be quickly and easily integrated to the crane, specifically with the types of installation requirements that are needed for a crane, typically side mounted and installed very quickly. So to show the installation of the Guidefast product a little bit more and to illustrate each of the components and how they work together, we have a short video that will show the system going together, give a rough idea of how it works. So the core of the Guidefast system is the plastic installation bracket, which we see being laid out here. That's typically installed at 1 meter centers along the crane girder. In this example, we're just installing it on a piece of racking for demonstration purposes. The steel guide trough then clips into that plastic installation bracket, and it's secured by a clamping block and a screw. And that's repeated at each installation bracket. And there's a clip that's attached to marry up the edges of the two troughs. Then the E-chain, which can be supplied from igus with cables already installed, as we see here, is simply laid into the trough, unrolled, and the system's ready to be put into service. So a very fast and easy way to integrate an E-chain onto a crane. I assume everyone out there is more or less familiar with igus energy chains, have used them on various different types of machines. Up until a couple of years ago, maybe 5 years ago, an igus E-chain installation on a crane may have looked something like what's pictured. This installation would still offer all of the benefits of an energy chain versus a Festoon or any competing technology. But we see here that there really isn't a great way to mount this guide trough system to the crane structure. So what's happened here is there's been a couple of pieces of angle steel that have been added. They've been welded to the structure, they've been drilled in a couple of places, and that's being used to support this guide trough. This will work fine. The only drawback of it is that it's a fair amount of work for the crane manufacturer or the end user to actually do this steel work. It needs to be welded, typically painted, drilled, and that's been a roadblock for certain customers looking to try and take advantage of some of the other technical abilities of E-chain. So that really was the goal behind the development of a Guidefast product maybe 5-6 years ago, was to simplify the installation and allow for really no welding, no painting, as little drilling as possible, something that really can be put together very quickly to reduce the overall installation time. So if we look at the components and the sizes that are available, as we saw, the install kit there is the core piece of the system. It's available in two styles, the long version or a shorter version. The difference being the amount of strain relief teeth that can be used to attach additional static cables, sensor wires, things like that, throughout the crane beam. So two variants there. It's designed to handle medium travels with relatively light cable fill. So when we say medium travels, we're talking typically in the range of 50 to 150 feet. Light filling, by that we mean maybe between 2 and maybe 8, maybe 10 cables total. It's available in igus 1500, 2500, and 2700 series E-chains. What that means in terms of actual dimensions is from the smallest size being 21 by 25 millimeters of interior space up to a maximum size of 35 by 100 millimeters of interior space. So we have a range of different sizes depending on the cable package, what the piece of equipment is actually doing, what size hoist. But we can usually fit anywhere from a couple of cables all the way up to between 8 and 10 in some of the larger sizes. And that really is, it's very rare for us to come across an indoor bridge crane application that we cannot handle within that scope of energy chain. As we mentioned, being ideal for indoor bridge cranes and shop hoists, that's really the number one application area for this product. Not to say that is the only application area. We have used this product in a lot of different types of applications where mounting on the side is advantageous, moving TVs, theater applications, plenty of things like that where mounting to the side is an advantage, but by and large, this is really the biggest advantages are offered to manufacturers and customers operating and making indoor bridge cranes and hoists. Now we'll go through, spend the next couple of slides going through the pros and cons of energy chain versus Festoons, and also how that relates to the Guidefast system in and of itself, and how the Guidefast system can offer some advantages specifically to crane manufacturers. So as we saw in the video, the way that the Guidefast system is installed is simply by one screw every 1 meter length. So you see the plastic install kits. Those are simply through bolted. We have some customers that will drill and through bolt. We have some customers that will use the stud welding gun and will weld a threaded stud on at 1 meter intervals. Both work equally well, just dependent on customer preference. But it's only one fastener that's needed every 1 meter length. Makes for a very fast and easy assembly. And we're also able to do two hoists in one single trough system. So if you are a manufacturer who frequently builds cranes that have two hoists on one beam, within that one trough system, we're able to do two energy chains. So we can feed both hoists with two chains running in one trough. The reason for that, and we'll see a little bit later with some of the additional graphics that'll come up, but the energy chain essentially only needs to be mounted in the center point of travel, and then it will travel half of the distance in one direction, half the distance in the other direction. So with that center fixed point, you can mount two chains, essentially a mirror image configuration. We call it an opposed configuration, and allow for both of the hoists to move back and forth with their cable management in a single trough system. Comparing that to the photo of the Festoon system on the right-hand side, first off, we see that there's a substantial amount of metal structure that's coming off of the crane beam. At a minimum, there are the horizontal supports to space the Festoon rail off of the main crane rail. You have some triangular gussets on the right-hand side, and then you have the longitudinal rail, which the cable trolleys will slide in. You have to have, what we see here is a crane that's set up for two hoists with the Festoon system. You'll see there's one set of Festoon cables that's fully extended in this photo and another set that's fully retracted. That's because a Festoon is not able to do multiple hoists on a single rail. This particular crane here is being set up for two hoists, and therefore it needs two Festoon rails. So a substantially greater amount of steel structure that needs to be fastened to the crane, a larger number of fasteners, more holes that need to be drilled. So it definitely becomes apparent which solution is easier and faster to actually attach to the crane beam. Next up, we'll talk about transportation. So one of the things that a lot of our crane manufacturing OEMs, people that are building these cranes as their core business and selling them to end users, they always want to be able to install these things into their customers' facilities as quickly as possible. Typically, they pay more for on-site labor that's installing, doing installation and service work at their customer, and their customer also wants their crane installed as quickly as possible. They want minimal downtime. If they have a project going on, they want it started and completed as quickly as possible. So in order to facilitate that, they try and do as much pre-assembly in the shop, in the manufacturing plant as possible. How that relates to Guidefast, as we see on the left-hand side, this particular manufacturer who we work with is able to install the Guidefast system onto the crane back in their shop. So they transport it down the road with the energy chain and the cables already there. So they get to the customer's site, they hoist it up, and just connect the ends, and there really is no work that needs to be done to install the cable management system as part of the installation at the end user's site. Comparing that against the Festoon system, you can see that the cable loops of the Festoon hang down below the bottom edge of the crane beam. The structure hangs out substantially farther than the width of the crane beam. So that would be much more difficult, if not impossible, to try and transport. Usually what would end up happening is that the Festoon system would need to be installed on site, which would lead to a greater amount and a longer duration of installation time at the end user's location versus work that could instead be done at the OEM shop. So next up, we'll talk about operational space. So we have two graphics here, the one on the top showing an energy chain and the one on the bottom showing the Festoon system. So first off, before we go into the dimension points here, we'll just see again what I was speaking about with the opposed system, where the fixed end of the energy chain is mounted in the middle here, and it basically goes half of its length this way and then half of the way the other way. So there really is no structure or energy chain needed in this area. So for a two hoist system, we can take a second one of these systems, flip it, make it a mirror image, put its fixed point right in the center, and let it articulate back and forth, doing the two chains in one trough system. Some additional points on operational area. An energy chain can be installed tight to the girder. Typically, the height is 18 inches or less of the overall system. That's driven by the bend radius of the cable. So the larger the bend radius of the cable is, the larger the loop height of that energy chain will be. Certainly can be reduced less than 18 inches, depending on the cable package. Smaller cables will bend tighter, lead to a tighter loop. But in this product, never more than 18 inches. There's also a fixed dimension loop station, which we see is with the 18 inches being the height of the green box. The loop station would be the width of the green box. So that is also driven by the bend radius. Smaller cables, smaller bend radius will lead to a smaller loop station, but that really is a maximum of 30 inches or potentially less depending on the cable package. It's important to note that that loop station, both the height and the width, will always be constant regardless of whatever the travel distance is. So if the travel distance is 50 feet, that area that's needed for the loop is 18 by 30 inches. Dimensions do not change if the travel goes to 150 feet, 200 feet, even more. It's always constant. That area is not usable space because the hoist cannot travel past that point to push the curve. So it's advantageous to keep that area of unusable space as small as possible. Comparing that with the Festoon system, you typically have loops that hang below the girder, as we saw in the photos on the previous slide. That can cause some problems with transportation. It can also cause some problems with operational space if the facility it's being installed into is particularly cramped. If there's racking or highly stacked material that those could potentially snag on or hit. But there's also the issue of the variable loop parking station, which can typically be between 10 and 20% of the overall travel. So we see that highlighted in red. The loop parking station here again being the width of the red box. So as the travel with a Festoon system increases, you need to add additional carriages with additional loops of cable, or you need to increase the depth of the loop. So if you have a 50-foot travel and it requires a certain amount of space, to increase that to 100-foot travel, you either need to double the height of the loops. So if they're hanging 5 feet, they now need to hang 10 feet, or you need to add additional carriages. So if you had 5 carriages, you now need to add 10. So as the travel will increase, the amount of space that the cable management system takes up will also increase. So with that being 10 to 20% of travel, on 100-foot travel, that could be as much as 10 feet. That is unusable space where the hoist cannot travel past into that red area. So with an energy chain, our usable space and our area of unusable space is kept to a minimum, regardless of the travel distance, maximizing the amount of travel distance for the hoist and clear space for working. Next up, we'll talk about the service and maintenance of the two different systems. With an energy chain, no parts are marked for wear. We say that once the system is put into service, if it is specified correctly and installed correctly, and it maintains installed in the proper configuration, it should be truly maintenance free. It should be set it and forget it, and the system will achieve full service life completely on its own without any additional intermediate service or maintenance. Cables are fastened into the energy chain by two clamps, one at the moving end and one at the fixed end. So if a cable did become damaged and needed to be replaced, or if there needed to be an upgrade, adding something new, the cable can be released at those 2 points. An old cable can be used to pull the new cable in. In certain cases, we'll even install pull strings that can be used to add things at a later date. Cables will be clamped back off at the 2 points, and the system can be put back into service. Comparing that versus a Festoon system, sometimes the trolleys do require a regular service, a lubrication, a greasing procedure. On smaller Festoons, sometimes that's not as much of a concern, but as the systems start to get larger, there do start to become some maintenance items that are required. Larger systems have some shock cables and tow cables, which serve to lessen the strain on the cable as the subsequent trolleys pull out. Shock cables and tow cables essentially are lanyards that tie the two trolleys together. We see them here in this photo where the longest line here is the cable, and then we have the shock cable and the tow cable inside here, which serves to tow the subsequent trolleys along. Those items also occasionally will need replacement, so it's a service item that the machine needs to be taken down to do that service. Also on cable replacement, replacing the cables requires disassembling a number of clamps. So we see that in just about all Festoons, the cable will be clamped at a minimum at the top, as we see across with the top set of red arrows. So in this scenario, we have 6 clamping locations. And on larger systems that use round cable or systems with longer loops, it's also somewhat common for the cables to be clamped at the bottom of the loop as well. So potentially as many as 11 clamps in the system. So one of the things that we've seen a large increase in demand for is modernizing equipment, making it more connected with the trends of Industry 4.0 and preventative maintenance, where we have a lot of customers that are wanting to add camera systems or additional sensors, additional monitoring devices to their equipment. And doing that typically will require additional cables. So if we needed to add a camera cable or upgrade a motor in an E-chain system, you just release the 2 cables, assuming there's sufficient spare space inside the E-chain. That cable can be added in with minimal to no changes, versus a substantially more difficult process if you're trying to do it to a Festoon system where the cables are fixed at potentially 11 points in this example, or potentially more depending on the travel. Next up, we'll talk about the cables themselves that go into the respective systems. With an energy chain, off-the-shelf round cables typically are used and combined. igus manufactures a complete range of all different types of electrical cables that are designed for use in energy chain systems. And all different types can be combined. Fiber optic, data, power, signal, whatever it is that's needed can all be combined into a single system, as well as different types of energy, such as hydraulics, air lines, media lines. It maintains a defined bending radius at all times, so that the manufacturer's suggested bend radius on the cables is always adhered to, and the cables and hoses will achieve full service life. Comparing that against Festoons, flat cables are normally used. There is a fairly comprehensive range of flat Festoon cable available for simple applications where just power and a bit of signal is required. Unique combinations, if you have a customer that wants some special additions to their cranes, sometimes the flat cables are not always available. Unique combinations can require either custom cables, where if a customer wants a special fiber optic element and an air hose or something like that, where either a composite cable needs to be made, which can be rather expensive and have a long lead time, or round cables can be used, but they require some special clamping elements to manage those cables on the Festoon trolleys. One other thing to mention with the flat cable, where all of the cable elements are essentially extruded together in one jacket, is that if a single conductor fails in that flat Festoon cable, say it's something that has 15, 20 conductors, if a single conductor fails, there isn't really a way to replace just the failed conductor. That whole cable needs to be changed. An energy chain is much more modular in nature, where you can place a power cable, a couple single conductors, data, the servo cable, whatever it is that you need. And if one element fails or needs to be changed out, replaced, only that element needs to be exchanged. The rest is able to stay in place and stay in service. And the last point on Festoon systems, as you can see here with the red arrows are indicating, Festoon does a fairly good job of maintaining a minimum bend radius around the saddle, where there is a structural component that fixes a bend radius. But at the bottom of the loop, there is no such component, so the bend radius can be exceeded, and the cable can also see some strain as it's pulled out and pushed back. So typically we are able to achieve a longer cycle life, longer service life of cables installed in an energy chain versus Festoon cables. Also, further on the cables, in terms of cable length and type of cable required, both of these systems, energy chains and Festoons, it's recommended to use a dynamic cable, a cable that's rated for continuous flexing operation. Continuous flex cables are by nature higher quality and therefore more expensive. So both systems require that higher grade cable to achieve a full service life. But where they differ is that an energy chain typically requires somewhere in the neighborhood of 51% of the travel of that high flex cable. So as we spoke about, the system travels half the distance one way, half the distance the other way. So if this is a 100-foot travel, we really only need 50 feet of cable to meet halfway, plus a small amount of cable to deal with the curve here and get back around going in the direction of travel. So we estimate that roughly at 51% of the travel. Comparing that against a Festoon, if a Festoon is going to do 100 feet of travel, it's going to need that cable all the way from point 0 to point 100. And it's also going to need a little bit of additional slack. So you can't have the cable pulled completely drawstring tight over that 100-foot travel. There needs to be some slack to allow for some flexibility. So that typically requires somewhere in the neighborhood of 110% of the travel worth of cable. So a 100-foot travel would require 110 feet of cable. So with the energy chain, it's possible to run lower cost static cable up to that center termination point and then run 51 feet of more expensive continuous flex rated cable inside of the system, and then make your terminations at the hoist. Whereas with the Festoon system, you'd typically be running your lower cost static cable up to the 0 point in the travel, and then you have 110 feet of that more expensive continuous flex rated cable. One final note on the cable topic, with igus, pre-populated systems are available direct from us. It's something that we do every day. We have an entire department devoted just to populating the energy chains with cables. As we saw in the video that played, pre-populated systems dramatically reduce the amount of installation time. The system can be delivered in a cardboard box, in a pallet, on a spool for larger systems, and simply unrolled into the trough. And sometimes, in case of it's a matter of minutes for smaller systems, that it's ready to go to be put into service. With Festoon systems, pre-populated systems are not typical. There are certain cases where Festoons are supplied pre-populated. It typically requires some special shipping arrangements, racking or transport fixtures. It's a substantially more complicated process, which starts to cut into the cost and the benefit of it. The cost starts to eat into the benefits of trying to facilitate a pre-populated system. Energy chain is much easier to deal with that pre-populated system and reap the benefit of that installation time. Next up, we'll talk about some of the resources that we offer. If you've been watching the webinar and are interested in trying out the Guidefast system in your facility, think you may have a need for it, we offer online CAD files and configuration tools for the entire Guidefast product family, as well as all energy chains, regardless of their size. So if it's something where you're looking to configure this and want to see how it fits onto your crane, we do have a full suite of 3D CAD data. We offer visits from our igus representatives. We do offer visits in all 50 states, as well as Canada, Mexico, and globally. We can conduct measurement surveys where if you have a system where you would like to implement this technology, you just don't have the time to deal with the measurements, gather the information for us, let us know. We'll be happy to come in and take that work on for you. We can identify cables as well. If you don't know specifically exactly what electrical requirements you just have a spool of cable that you pull off of to build. We can help to identify those electrical requirements, specify the right cables, and design a complete system and provide a quote. We offer on-site installation service. So if you have manpower issues on the service side, we are able to offer an igus team of people that can come in, install these systems directly onto the crane for you. Or if it's something where you do have a dedicated service team that has plenty of capacity, they just may not have the know-how to deal with a new product like this. We also offer on-site training where igus personnel will travel to your location. They can work with your service personnel to install the first one and train them on best practices so they're equipped to do subsequent systems. And then one final thing that we offer, if you are a crane manufacturer, if you're producing cranes as part of your daily business and maybe have typically used Festoon systems, you're interested in a Guidefast system, but maybe don't believe in it enough to put it on a system that you're going to ship off and deliver to a customer, we're happy to offer what we call a test drive system, where we'll give you a free system that you can put either on on an in-house crane or a crane that's going to a local shop where you can monitor it and allow you to evaluate the performance of the Guidefast system at no cost. So we're happy to discuss opportunities for test drive systems wherever the case may be. So if you feel that that may be a good fit for you, please reach out and we'll be happy to discuss further. And then finally, this presentation has been purely on Guidefast, which is devoted to some more medium distance travels with cable fill packages towards the lighter side. igus is certainly able to do much more than just the Guidefast type and size applications. If you've been watching this webinar and say, it's good technology, I like the energy chain, I like the benefits that it offers versus a Festoon, but my application is just a lot bigger than what these applications have been discussed thus far are. We have a complete range of sizes and styles to deal with just about any application that you could think of. We have a couple application references here of many that are some of our things that we've done on the larger side. One being a taconite mine in Minnesota, which to our knowledge is the longest cable carrier travel in the USA at 1,804 feet. It's been in operation since 2009, at temps reaching as low as -31 degrees Fahrenheit in the Minnesota winters. That's shown in the picture on the left-hand side. The photo on the right is a project called the Amherst Project in Belgium. It uses the largest plastic cable carrier in the world, which is the igus E4 350. Carries a 12-inch diameter sludge hose for a dredging operation. So as the dredging application is carried out, the mud, the rocks, the silt, the sand is pumped up through that hose, which is carried by that very large energy chain that you see in the two photos in the center and on the right. So that will conclude the webinar for today. Thank you guys for joining and listening.